Hi, it's Tuesday. Welcome to math class. Okay, to start off for today, we're going to derive the formula for the area of a trapezoid. Let's watch this video. It's called Area of Trapezoids by Anywhere Math. And if you're interested in watching more of this video, because we're only going to watch a couple of minutes, you can find the link to this video in my description on my YouTube channel, Math with Mrs. Jones. Okay, great.
Welcome to Anywhere Math. I'm Jeff Jacobson, and today we're going to talk about how to find the areas of trapezoids. Now, before I show you what the formula is for how to find the area of a trapezoid, let's look at where the formula comes from. Okay, let's talk about where the formula for the area of a trapezoid came from, because that's really important to know where it came from. These formulas don't just appear out of thin air. There's a reason behind it, and if you understand where it came from, it gives you a deeper understanding of how to find it, and hopefully you're not just concentrated on memorizing the formula, because memorizing stuff isn't any fun. It's much more interesting to know where it came from. So here is my trapezoid. It's got four sides. It's a quadrilateral, like I said earlier, and it has exactly one pair of parallel sides. These little arrows here mean that this side and this side are parallel with each other. So now let's label. Your parallel sides, you're always going to call those bases. And it doesn't matter which one you label which, but this top one, I'm going to call that B1 for base number 1, and this bottom for base number 2. Remember, your bases are always going to be those parallel sides. So it doesn't matter if this is flipped up or rotated over. Wherever your parallel sides are, those are going to be your bases. And I could call this B2 and this one B1. It doesn't really matter. Then the distance between your bases, right here, is going to be your height. Okay, and same thing, even if it's kind of rotated a little bit and might not look like a typical height, the distance between your parallel sides will be your height. Okay, so look for that. And it's always going to be, your height is always going to be perpendicular, right? That's what that means, to your bases. Now that we have my trapezoid kind of labeled, let's look at where the formula came from. If I draw a little line here from the midpoint on this side all the way up to here and cut this little piece off and rotate it and then slide it down, well, now I've made one big triangle. Okay, and notice the area didn't change. I still have the same amount of red, right? I just cut a little piece off and moved it. That's all I did, rotated it and then moved it down. So the area hasn't changed from my original trapezoid. So now it's just a triangle. And to find the area of a triangle, we know it's just base times height divided by 2. Well, what is my base? Well, my base is just going to be my original B1 plus my original B2. If I add those together, that will be the base of this triangle. The height is still this height. Okay? So to find the area of this triangle, I would do B1 plus B2 times the height, and then divide all of that by 2 because it's a triangle. So with that in mind, here are the formulas for area of a trapezoid. You can either think of it this way, right? B1 plus B2 times that by the height and then 1/2 of that. Or you can think of it as this way. Again, B1 plus B2 in parentheses, do that first, times your height, and then divide all that by 2. They're the same formulas, just written different ways. So whichever one you're more comfortable with, kind of concentrate on that. Lastly, if you're wondering, well, does that work for any trapezoid? Yes, it will. Obviously, I'm not going to show you all different trapezoids, but yes, believe me, it would work for any trapezoid. Okay, example 1. Find the area of, well,
All right. So, in summary, the area of a trapezoid is 1/2 times height times, and in parentheses we have base 1 plus base 2. Or you can write it as 1/2 height times and then in the parentheses, base 1, b1 plus b2. Now, the parentheses mean that we should solve whatever expression is in the parentheses first, right? Then we can do the other multiplication operations. All right, so let's find the area of a trapezoid. Okay, let's look at this example, and I'm gonna actually increase my little mini video screen here. All right, so in the figure, TUVW is a trapezoid. Line TW is parallel to line UV. Find the area of trapezoid TUVW. Okay. All right, so clearly I have my bases, which are TW and UV, and I have my height, which is the distance between my bases of 14 centimeters. And not only is it the distance between my bases, but it's the distance that is perpendicular to both of my bases. So here, okay, I inputted in my B1 as 12 and my B2 as 26, all right? And so I'm going to solve for the parentheses first. 12 plus 26 is, let's see, it's 38, right? And then we're going to multiply it by 14 and multiply it by 1/2, okay? Immediately I see that I can do half of 14, right? Here, half of 14 is 7, and then I have to multiply that by 38. I don't know this off the top of my head, so I'm going to just do it on the side here. 38 times 7, that's 56. 7 times 3 is 21 plus 5. 21 plus 5 is 266, okay? And let me see, this is the area, so I need to write square centimeters, like so. Okay, all right. Okay, now it's your turn. Please pause the video and try this on your own, and let's compare our answers when you're ready. See you soon. All right, welcome back. So we're going to do 7 and 8 together. Now look at trapezoid 7. I see that my bases are parallel to the ground, right? But look at number 8. My bases are not parallel to the ground. So what I'm going to do with number 8 is I'm going to turn around my trapezoid so my bases are parallel to the ground, like so. Okay, now I'm ready. So in number 7 and 8, they ask you the height first, but before I do the height, I want to find the sum of the bases. And before I find the sum of the bases, I have to figure out what are the bases, okay? And so for 7, I see those two are the bases, and for 8, in my picture that I manipulated and turned around, I see that those two are the bases because they're parallel. And so the sum of the bases for 7 is 3 plus 7, which is 10 units. And for number 8, the sum of the bases is 1 plus 3, which is 4 units. Now I'm going to input that into my formula for the area of a trapezoid. Okay. Oh, before I do that, I'm going to find the height, of course. How can I input that in without finding the height? So I got to find the height. So the height is just the distance between the bases, and that distance has to be perpendicular to both bases. Okay, so you can find it. If it's easier for you to draw it inside the trapezoid, do so. If it's easier to draw it on the side of the trapezoid, you can do both ways. Okay, both of those types of lines, the solid line and the dashed line, show you the height, the corresponding height. So for number 7, the height is 3 units. For number 8, the height is 4 units. Now I can input in everything into my formula for the area of the trapezoid. And right here, okay, for number 7, I see that 3 times 10 is 30, and half of 30 is 15 units, or 15 square units, I mean, because it's area. And then now here, I see that 4 times 4 is 16, and half of that is 8 square units. Ta-da! I thought that guy was pretty funny. All right. Please do 9 and 10, and I'll see you in a couple of minutes. Hey, welcome back. All right. Let's do 9 and 10 at the same time. Okay. Again, for me, it's easier when I look at a trapezoid to determine the bases first. I don't know about you if that's easier. You're gonna have to kind of practice a bit to see what's easier for you. For me, it's easier to determine the bases first, so that's what I'm going to do. And it looks like both of my bases for 9 and 10 are parallel to the ground itself. So I don't believe I need to manipulate any image to help me. So I see that my bases are that, okay? So the sum of the bases for 9 is 7 plus 4, which comes out to be 11 units. And for number 10, it's 3 plus 5, which becomes 8 units. And then I have to find the height before I input in my sum of the bases and height into my area formula. So my height is the distance between my bases, and the distance has to be perpendicular to both of my bases, and you can use either lines that you see there, and the height is 7 units for both of my trapezoids. Now I'm ready to input that in, and I get this, okay? And for here, I see that 7 times 11 is 77, and half of that is 38.5. And here, 7 times 8, well, I'm going to do half of 8 first. So half of 8 is 4, and then I'm going to do 4 times 7, and that's 28 square units over here. All right. Okay, you know what to do. Pause, and I'll see you soon. Hey, you're done already? Okay, so for number 11, what I immediately noticed was that my parallel side to my trapezoid is not parallel to the ground. So I manipulated the image so that my bases of that trapezoid are parallel to the ground. For number 12, I didn't have to manipulate that image for the bases to be parallel to the ground. So now I'm ready. I'm going to find the bases first and then find the sum of the bases first. So for number 11, it's 25 and 13, which makes 38. For number 12, it's 10.6 and 21, which makes 31.6. Now I'm ready to find the height. And the height is just the distance between the bases that is perpendicular to the bases. Okay, so the height is as follows, as you can see in the picture in the red line. So for number 11, the height is 39, and for number 12, the height is 13. I'm going to input in those values into my formula for the area and base. And I just thought for this one, let's just do it together, okay? Or I'll just show you, and you can double check if you kind of get a different answer than what you got. So let's see. Well, half of 38. I'm going to do half of 38 because that's the even number, so I can divide it by 2 very easily. What's half of 38? Let me see. I know half of 30 is 15, right? So it must be 19. 19 plus 19 is 38. Okay, so half of 38 is 19. So now it's 19 times 39. Okay, and then I'm going to multiply it here on the side. Okay, 9 times 9 is 81. 9 times 3 is 27, plus 8 is 35. And I'm going to cross that out since I already used it. Okay. Now I'm going to do 1 times 9, which is 9. And I'm going to put it here. Right? Not here. I'm going to put it here. Okay. And now I'm going to do 1 times 3, which is 3. And then I'm going to add this. So that's a 1 and a 4, 6, and a 7. Okay. So my answer is 741 square feet. That should be a T. All right. Okay, let's look at number 12. Okay, so these numbers are hard for me to find half of something. I mean, I guess half of 13 would be 6.5, but yeah, half of 13 is 6.5, so maybe I'll do that first. So 6.5 times 31.6. Okay, so when I have this, I'm just going to stack it up like this and multiply it. And for now, I'm going to ignore the decimal point, but I'm going to take note. Here, there's one decimal place that comes after the decimal point, and here, there's also another one decimal place that comes after the decimal point. So I'm going to take a note here. Okay. Now I'm going to multiply as usual. So 6 times 5 is 30. 5 times 1 is 5, plus 3 is 8. 5 times 3 is 15. So then I'm going to cross out that 3 because I already used it. Okay, so now I'm going to go here. 6 times 6 is 36. So I can write a 3 and a 6 here. 6 times 1 is 6, plus 3 is 9. And then 6 times 3 is 18. I'm going to add that. Okay, and then I see that, okay, when I add this is 2 here, so that means I have to move this over 2 decimal places here. So my answer is 195.4, and my units are square centimeters. Oh, it's 205.4. Okay, let's see what I did wrong. Okay, half of 13 is 6.5. Can you find what I did wrong? Maybe you guys can find it. And then 31.6, 21, 31.6. Okay, let me see. So that's 0, 3, 5, 0, 3, 5, plus 3 is 8. Then that's 15. That's a 36. Then that's a 9. That's a 18. So now I'm going to add it, right? So 0, 4, 1, 15, 1. Oh, this is a 10. I didn't add this tiny 1. Okay, there we go. It's 205.4. I found my mistake. Okay, did you catch my mistake as I was going through it? Maybe you got it right on the first time. So, oh, way to go. If you were able to catch my mistake too, good job. Way to go. All right. All right. Well, I'll see you tomorrow on video. We have one more session on video, and then I'll see you on Thursday in person. Okay? All right. Bye. I was going to say, get your questions ready for Thursday.